On September 16, 1997, a small team of people interviewed atheist Richard Dawkins in his house. At one point, the female interviewer asked Dawkins the following question: "Can you give an example of a mutation or an evolutionary process which can be seen to increase the information in the genome?" The video makes it seem that Dawkins, a leading author on evolution, was completely stumped by this question, pausing for 11 seconds before finally having to say, "Can you just stop there?" Of course, there are several problems with this assertion. Just so you know, of the 5 that will be mentioned, the last one is the clincher. So the first several are introductory or less convincing than the last. First, it turns out that the interviewers were creationists. That gave them a motive to misrepresent Dawkins. They also had the opportunity and the means. Creationists are well known for quoting scientists out of context in order to advance their anti-evolution cause. If the interview had been conducted by disinterested people with no axe to grind against Dawkins and evolution, then the claim would carry more weight. But it's not. It comes from a partial biased source. 2. It's quite possible that the video was edited. Dawkins' stumped appearance does not begin after the interviewer asks the question. Instead, he has the same stumped expression from the very beginning of her asking the question, before he had any idea what was going to be asked, all the way through her finishing the question, and then 11 seconds after that. This is not what one would expect to see if the creationist assertion were true. Further, when the video picks back up, it is clear from what Dawkins says that he is answering a different question, not the one that allegedly stumped him. Dawkins himself also has pointed this out. But the video gives the false appearance that Dawkins is trying to answer the question that quote-unquote stumped him. But he can't answer it, so he evades the question in typical politician style, dancing around the point without ever addressing it. That's a misrepresentation. 3. Dawkins gives us a plausible explanation for why he paused. He says that he was not stumped, but rather that it was when that question was asked that he finally realized that it was creationists who were interviewing him, and so he began pondering what to do about the situation. For example, should he end the interview right there and then and tell them to leave? So he was pondering how to handle the situation, not trying to think up an answer to the question. Point 4. Only Dawkins knows. The only person on the face of the earth who knows what Richard Dawkins was actually thinking is Richard Dawkins himself. The creationists don't have direct access to Dawkins' brain the way he himself does. Therefore, a rational, honest, unbiased person must take his statement about what was going on in his own head as being accurate and the default position to accept. The creationists have the burden of proof. They must convincingly demonstrate Dawkins was actually stumped, and they can't do that. Point 5. This one is the clincher. Dawkins already answered the question. I can show excellent reason to accept that Dawkins was not stumped by the creationist question, and the evidence is easily confirmable. Dawkins had explained how genetic information could be added to genomes more than 10 years before the interview. The interview took place on September 16, 1997, but in Dawkins' 1986 book, The Blind Watchmaker, he mentioned more than one process that can add information to genomes. Here's a quote from his book. "One of the main things that must have happened in the early evolution of living organisms was an increase in the number of genes participating in such cooperatives. Bacteria have far fewer genes than animals and plants. The increase may have come about through various kinds of gene duplications. ... The main point was that the total genetic capacity of a species may increase due to gene duplications." That's good. I mean, that right there should probably settle it. But technically, so far, that only shows that genetic capacity, not genetic information, can be increased. Not a problem. Dawkins then goes on to give an example of how repeated gene duplications and divergence among duplicates can increase genetic information. He devotes a long paragraph to discussing an original globin gene that, through duplication of it and some of the resulting duplicates, with divergence amongst the copies following duplication, formed a family of 8 different globin genes. Here's a quote from his book. Humans have 8 separate genes called globin genes, used for making hemoglobin, among other things, on various different chromosomes. It seems certain that all 8 have been copied, ultimately, from a single ancestral globin gene. About 1,100 million years ago, the ancestral globin gene duplicated, forming 2 genes. We can date this event because of independent evidence about how fast globins habitually evolve. See chapters 5 and 11. Of the 2 genes produced by this original duplication, one became the ancestor of all the genes that make hemoglobin in vertebrates. The other became the ancestor of all the genes that make myoglobins, a related family of proteins that work in muscles. Various subsequent duplications have given rise to the so-called alpha, beta, gamma, delta, epsilon, and zeta globins. Continuing the quote, the fascinating thing is that we can construct a complete family tree of all the globin genes, and even put dates on all the divergence points. Delta and beta globin parted company, for example, about 40 million years ago. Epsilon and gamma globins 100 million years ago. Yet the 8 globins, descendant as they are of these remote branchings and distant ancestors, are still all present inside every one of us. They diverged to different parts of an ancestor's chromosomes, and we have each inherited them on our different chromosomes. Molecules are sharing the same body with their remote molecular cousins. It is certain that a great deal of such duplication has gone on all over the chromosomes and throughout geological time. Furthermore, that gene duplication followed by divergence could add information to genomes was known at least as far back as 1970, when Susumu Ono's book, Evolution by Gene Duplication, was published. The above quote from Dawkins is definitive, but there's some icing on the cake too. He goes on to say in the very next paragraph, here's the quote, duplication within a species isn't the only means by which the number of cooperating genes has increased in evolution. An even rarer, but still possibly very important occurrence is the occasional incorporation of a gene from another species. And on the next page, page 176, Dawkins goes on to talk about what is now referred to as symbiogenesis, or the endosymbiotic theory. Here, 2 genomes are combined into a single genome. For example, after a proto-eukaryotic cell incorporated a prokaryotic cell as an endosymbiont, the host then had 2 genomes in it, what came to be, today, the nuclear and the mitochondrial genomes of eukaryotes. As is clear from the quotes from his 1986 book, The Blind Watchmaker, Richard Dawkins had already answered the creationist evolutionist stumping question 10 years before it was even asked. And he gave more than one answer for it. And it really doesn't matter. Let us remember that if, contrary to all the evidence, including his multiple statements in his 1986 book, The Blind Watchmaker, if Richard Dawkins could not explain, whether before, when, or after being asked the question, how genetic information can be added to genomes, plenty of other biologists could have and still can. So the entire creationist point, if it is meant to be anti-evolution in any way, is moot to begin with.